podcast, What AI Means for Us. It's great to have you here today. How are you?
Hi, Chris. Everything okay? Fine. How are you doing?
Yes, great. Really excited for this one. I think we've chatted in the past about research in general, and you've been a great fountain of information for me to learn. And I thought, why not get you on the podcast and let other people learn from you as well. For those that don't know you, your research or your background started in NLP research at the University of Amsterdam in NLP and deep learning. And that then you went on to work at Amazon and Cohere. And I think one thing I've grown to admire about you, Marco, I speak to a lot of researchers, is your attention to detail and you're super on the pulse. And do you welcome, and do you want to just give people a bit more of a detailed overview about your background, starting during your PhD, etc.?
Yes, of course. Well, thanks a lot for the nice intro. You touched upon already the main things. I would say that I have a sort of peculiar trajectory since I started from from humanities. Actually, my main my topics when I was studying during my master, it was formal linguistics or linguistics more in general. So I was focusing on things such as syntax and morphology and semantics, pragmatics, these kind of things, and not really it was not really in the domain of engineering or computer science. Then toward the ends of my masters, I took a course in computational linguistics, and I found it super interesting. And this is where I started to understand, or to think about the connection between, let's say, the computer science domain and linguistics. And then let's say that my journey started. So I did my thesis into this, and I grew more and more interested in the topic. Then I looked for a PhD. And as you were saying, I did my PhD at the University of Amsterdam in the Institute for Logic, Language, and Computation. That was a really wonderful experience. I worked on, let's say that in general, since the topic of my PhD in general was the interaction between language and, let's say, external extra-linguistic context. And by this, I mean that back then when I started my PhD, most of the studies on language on the field of NLP and computational linguistics were about formal language like those in the newspapers and so on, while I started to work on language produced by users on social media. And the idea is how to better understand language by having information from the people that were producing language. So for example, how can I better understand a tweet from you if I know who you are? And the point is, on the one hand, of course, creating representation of linguistic information, and the other hand, that means creating representations of you as a user. And I explored way to bring these two pieces of information together, and of course to see how this could be used to perform tasks and so on. So it was a super interesting experience. I had the chance to visit great groups in Barcelona, in Stuttgart, and to go for a few research visits and also for a few internships. One was in Amazon and in the research lab in Barcelona. And since it was a successful one, they offered me a return offer, which I accepted. And I joined Amazon Alexa. And that was fun time. When I joined Alexa, I was still pretty, well, unable to manage proper conversations. So if you would ask, who is the president of the States? And then we say Biden, and then we say, how old is he? He wouldn't know who we're talking about. So we work mainly on this, on what I would say like contextual carryover, or being able to get into multi-turn conversations. And that was more or less my focus when I was there. I met wonderful people there, really great researchers, really great time. Then with the rise of like the coder style model, I joined Cohere. When I joined back then, it was still a relatively small startup, and then there again, great people working mostly on RAG at the beginning. Again, RAG was a pretty new thing when I arrived, and I had the chance to work with a very good like a group focusing on this. And then the second part on agents, basically, agentic LLMs. Again, something new, again, something to discover. And then from there, I jumped to Twin. And Twin is working on agents, like autonomous agents, which is a very, very brand new space. As you might infer from this intro, I chase new things and explorative work. So yeah, high level.
Yeah, thanks for the intro. I think your career seems to evolve perfectly with the market through RAG, LLMs, now agents, and yeah, it's a nice transition. I think when you kind of made that career, jumping back to your PhD, made that transition from your PhD into industry. What were some of the things you learned? Going into kind of a top organization like Amazon from more academia. What helped you make that transition?
Well, let's say that the, on the one hand, for me, it was somehow easier, I would say, because I've always liked to work on some real world use cases. So, for example, during my PhD, I was working on fake news detection. And this is something that was, for example, very interesting for back then for Facebook and these kind of things. So I've always liked to deal with data from real world people and working on real use cases. So this, and I'm saying this in comparison to some colleagues of mine that would do, like, for example, a more basic not basic meaning that it was easier, but like exploring some more properly linguistic mechanism and so on. So for me, the fact that I had already been working on real world use cases somehow made me feel pretty comfortable as I moved to the industry. I knew that this was going on, that this would happen, and this was like I had a confirmation. And then, of course, like clearly you have to get into a bit the dynamics that happen in the big companies. Like, for example, the fact that there is research, but then there is also the part that is related to shipping to product, which both were important in Amazon, in Cohere, in Twin. So you learn how to balance the two things. You know that there are moments in which you can dedicate more time to research, and then you can like push into this, and some others in which you have to work more on the actual product outcome. Typically, supervisors are more happy when you push on the product. So you have to find you learn, let's say, how to balance the two things, and you learn how to do research, always keeping an eye on the product side by saying, okay, I know that I'm developing this. I know that I'm doing experiments on this because this will end up there. And so yeah, this was probably the thing that I had to learn. But this was I mean, I was lucky because especially in Amazon, all the people that I was working with had a background that was similar to mine, so they would understand where I was coming from, and they would help me in this transition.
Yeah. So to summarize, I think focusing on real world problems, and there was a company and researchers there that had been on the same journey as you, and that helped you, I guess.
Yeah, exactly.
Cool. Well, yeah, we'll get on to the next part of the podcast, which is broken into LLMs and evaluations, something you touched on quite a bit at Cohere, and then autonomous systems and AI agents, which is what you're moving on to now in your research. I think that's pretty cool, and something to it's a buzzword at the moment in the market. So yeah, do you want to just kind of go over kind of where you see LLMs going over the next couple of years, and are we now hitting limitations in that technology? Certainly, you see certain articles in the marketplace that we are, but what do you actually think of that?
So like general, like in general, not only about evaluation, like where the LLMs are going in a couple of years, right?
Yeah, that'd be great.
Okay. Well, first of all, I believe it's pretty hard to make a prediction on such a long time span, because if you think about it, now it's beginning of 25, and ChatGPT came out at the end of 92. Of 22, November 22. So it's slightly more than 2 years. It's 2 years and 2 months, if I'm correct. I might be wrong, but not that much. And think about how many things have happened. So it's really hard. At a high level, what I can say is that like there are some trends that they seem to becoming more evident. Like for example, that the scaling law of data and computation it seems that is maybe reaching some plateau, meaning that it seems that it's not only a matter anymore of having more data and more computational power to get better and better and better models. It's hard to, of course, compared to the past, it's hard to make like precise statements on this, because like the main LLMs are not, we don't know the details about them, and therefore it's hard to make it's hard to have a clear position. But the point is that there seem to be like rumors saying that we are kind of reaching plateau. So and this makes me think about what might happen, like in terms of limitation of technology. That is, like if we are reaching a plateau whereby basically it will not be enough to just add data and add computational power, what will we do? So, and something that is coming out that has come out in the last month, for example, is then like focusing on the inference time. That is not only the time that you spend to train the model, but the time that you spend like to produce inference, which basically boils down to let the model like think more and like to give it more time for reasoning and so on. But so this is another path, another direction that might be taken, which makes complete sense to me. And on the other hand, like on a bigger scale, though, I think about the basic architecture that now is the one that like underpins all these models that we're using now, like the decoder part of the transformers, basically. It's interesting because if I think back about my PhD, like basically we were working with a lot of different architectures, and there was a lot going on about like playing with LSTM, GRU, or graph convolutional networks. There was a lot of variety, and you would play with all of them and so on and so forth. While basically since transformers have come out, and like that was already should be 7 years ago, 7 years ago, something like this. There is almost no discussion about the fact that this is the de facto architecture that we are all using, actually as a part of this, because it's only the decoder. So, and there are some limitations that are well known about this. So my question is, will we stick on this, or there will be another step in which something else will come up that will replace? Because of course there have been improvements, but the basic architectures have stayed the same. So this is the thing that interests me the more, like saying, okay, not necessarily the most, but like saying, okay, will something else come up that will disrupt the current scenario completely? and that will change the current picture completely. That would be interesting to see.
Yes, it certainly is interesting. No one actually knows, I guess. But in terms of evaluations and work you've done, more of a high level in terms of LLM evals, it's certainly still a hot topic going into this year. Where do you see the market going there?
Okay, so evaluations are a very interesting topic for me that I've been working on and I still work on. First, it's worth setting a bit the scenario. So only a few years ago, before the generative models and so on, evaluation was relatively simple. There was F1, there was accuracy, there was precision and recall. That's it. And you will live with that, and you will have basically, I wouldn't say no discussion, but little discussion about how to measure models' performance. There were some already, there were some more advanced metrics back then, like, I don't know, blue, rouge, and this kind of things, like used mostly in translation. And while as we started to have like generative models, we like more, my feeling is that almost always the development of the improvement of model capabilities have been more advanced than our way, that our approaches to properly evaluate them. What I mean is that, like, at the beginning, for example, when I joined Cohere, there was not only in Cohere, but for all those that were developing like foundational models, like how to properly evaluate fluency, grammaticality, and so on and so forth. And there were two interesting aspects about that. First, that it wasn't immediately clear how to do that. And second is that the importance of these metrics quickly decreased, because at some point it was clear that the models were perfectly grammatical. So why bothering keep measuring it? Because it was not needed anymore. But then, like, new metrics come out. For example, I don't know, all the metrics related to safety, all the metrics related to alignment to humans' preferences, and so on. And new problems came out with them. For example, the fact that even the inter-annotator agreement. So when you have like a question and an answer, and you want to create the gold data for this, you have like humans annotating it. And then if you have, I don't know, n humans, then you measure the inter-annotator agreement. So how much the annotation from the humans are homogeneous versus how different they are. And many times the human annotation agreement was very low because it was less defined, it was more fuzzy what we wanted to evaluate, and not even the humans agreed on it. And then, like, other things, for example, I was working in RAG, and I was actually focusing on the evaluation framework that we implemented. And for the new measures like faithfulness, for example, came out. So faithfulness is given a question and a set of retrieved documents, and you want to and an answer generated on these retrieved documents. How faithful is, or grounded, it was another name, groundedness. How grounded is the answer on this? It's not easy because because sometimes you might, the limit between what is actually there in the document and what you can, for example, infer from what is written, it's not well defined. So this part is to say that as the capabilities of the models increase, and as they become as they become more intelligent, more smart, or able to perform tasks, let's say, it's more and more hard. It's harder and harder to have a clear grasp or a specific measure about how well they do in general. So I believe that, for example, where I'm now, it's easier, rather than developing, let's say, very, very general metrics that measure the performance of the models overall, to develop specific metrics for the tasks that you want to do, that you want to be precise for. So, for example, let's say that now that I'm working with agents, I want the agent to navigate a website until it performs a specific task, for example, booking a flight to London. And that is easier because it doesn't measure a very, very high level ability of the model. It measures a very specific task. I want you to do this. Did you manage or not? So in general, this is the specific case related to what I'm doing at the moment. But in general, what I try to say is that by defining very specific tasks, which are of course related to the business of the company, for example, that is using that LLMs, it might be easier to have very specific metrics that give you a clear understanding of what the model do on that task without assessing the overall abilities of the model.
Yeah. So would you say the fact that agents coming out now are very specific, it's easier to measure, but potentially as they become a bit more general, it might become, I guess, more challenging again?
I mean, the other side of this is that you have to have very tailored metrics for any task that you have to do. So you will never have a high level understanding of model capabilities. You will have only a very precise understanding on the very specific thing that you want the model or the agent to do. It's a matter of probably, I mean, the broader is the capabilities that you want to measure, the more difficult it is to catch them. While the more specific you go, the more focused on a specific task you are, the easier it is to measure that.
Cool. Thanks for sharing that. And I think, I guess $1 million question is, what would you consider the gold standard for evaluating LLMs in general would be the gold standard metrics? I know you touched on a few there.
Yeah,
Around
exactly.
groundedness.
I mean, considering that, well, there are all these metrics related to like reasoning, maths, coding, and so on that are somehow part of the training, that are somehow required as you perform the training of a foundational model, no? So I don't know, MMU or other data sets that measure these specific things. And probably I would say that since nowadays every model is expected to provide true answers and grounded answer because RAG is somehow a default right now. Probably these two are the things that you expect as the basic things like faithfulness or groundedness and the fact that the answer is correct. So these are the two things. But again, now since models are like used in the industry in so many different tasks, the gold is what you need. Basically, yeah. I would say that the gold is what you need.
Okay, fair enough. And next question, in terms of it, interpretability and explainability of models, what steps can you take, or what examples can you give where you potentially can explain the model clearly?
Yeah, I believe I myself worked on interpretability during my PhD and also during my time in the industry. I would say there are two main ways, not to look into interpretability. One way is to look into the models. So it's often said that, or it used to be said, now that I think about it, that I don't hear this expression that much anymore. But like they often say that large language models are black boxes, no? Or whatever AI, which to some extent is definitely true. But also not completely true. What I'm trying to say is that you can actually look into the activation patterns that happen in the model in order to have a better understanding of some mechanisms of and basically the kind of the internal representations that the model create given an input. And of course, based on this representation, the model will create an output. So this kind of approach was very common a few years ago. Again, as I was mentioning during my PhD, like there was a lot of studies going on like looking into the internal activation of the models into the internal parameters. And I have a bit the feeling that this is less prominent right now, even if only exactly a couple of days ago I read a very interesting paper about this, so it's still an active line of research, and I think it's still valuable to look into this. Like, of course, this becomes more and more complicated as you have models with billions of parameters, plenty of layers, and of course, provided that you have access to these parameters and to the activation patterns. So while then there is the other way, that is like to look, I would say, indirectly into the model, that is by asking the model to provide you explanation about what the model is doing and how it's proceeding. So I know I'm maybe like it might be too vague as a definition, but I would define this as all the approaches descending from the initial chain of thought approach, no? In which basically what you do is you ask the model, okay, perform the task, but in order to perform the task, please explain which are the steps and tell me what you're doing. And this was initially developed mostly or also because by doing this, the model itself becomes better at performing that specific task. By detailing the steps, the model helps itself to produce a better answer. But of course, like the other very important thing is that you can look into what the model is thinking, and like with many quotes. So I would say that this is definitely the way to go, and this is also an approach that we use a lot, like everything that is related to like defining the steps, defining the details of the thinking, defining adopting approaches like self-critics, in which the model itself analyzes what he has thought, and then it tries to look for flaws or for problems into it and to fix them. So this is I would say the main way currently like the understanding of the inner processing of the information by the model is done, and like there are, as I was saying, like starting from the initial idea of this chain of thought, there were many other approaches that came out, but the underlying idea is more or less the same for all of them. So to let the model explain what it's thinking about and what it's reasoning on.
Yeah, it sounds quite straightforward when you say it like that, but I'm sure it's not. Okay.
Which part is not the one? The first part of looking into the model activation, or the one of the asking the model? Because asking the model is actually rather simple. You just ask it to details.
Fair enough. Yeah, it sounded like one of those things where you when you say it out loud, it sounds simple, but when you actually come to do it, there's a little bit more to it. But okay,
Of course.
cool. Moving on to the kind of autonomous systems and agents part, as I said at the start of the podcast, agents becoming much more mainstream. I don't think there's a more used buzzword on LinkedIn right now than AI agents. Before we get into the fundamental research, I guess there'll be people that are listening to this that don't know or hearing different definitions of what an agent is. Do you want to start by just really giving a simple explanation of what an AI agent is and how it could actually help someone?
I wish I had it. No, what you're saying is true, or at least I agree on. There is a lot of discussion going on agents, but there is, as far as I know, there is no single clear definition of what an agent is. I believe that I read a blog post some time ago in which they were citing Henry Rangi, and I don't know if I didn't check if he is actually the one who said that, but the quote was that it's hard to define what an agent is. We can talk about sort of scale of agentic behaviors, let's say. So rather than saying, okay, this is an agent and this is not, we can think about it at what are agentic behaviors. That are several, and now we can go a bit deep into this. And like you can have some of them. So being an agent rather than being a binary situation, yes or no, is a more graded situation. There are several levels of agentic, we say. And this, I believe, it makes sense because this explains why there is not a single unique definition of what an agent is and what is not. So from my point of view, an agent is, first of all, at a very high level, you can define it something that is a piece of software or whatever that is built around an LLM. Okay, so there is always an LLM at the core, and at least in the current formulation of the agents. And then basically what you can have as an agent is like what you would expect as an agent is the ability of, given a task, I would say, from my point of view, the crucial things are the ability of reasoning on the task and coming out on a plan on how to do that. And this is crucial because most of the time, the implicit assumption is that what you give to agents are complex tasks, not like simple questions. Therefore, like coming up with a plan is the first important thing. Not only coming up with a plan, but also the ability of replanning as the agent goes through the steps if something goes wrong. So I would put all of this like in the general bucket of the reasoning capabilities. The second important thing for an agent, like for the agentic behavior, is tool using. So the ability, like given a set of available tools with a description, with some parameters and so on and so forth, the agent has to be able to use them. These can be most of the times APIs that the agent can call. And this, of course, empowers, like give the possibility to the agent to interact with tools out there in the world. So this is definitely crucial. Then from my point of view, another crucial thing is like being able to collect and leverage information as the model goes through the task. I mean, it's the model has the agent has to be able to take steps, save these steps in a sort of memory, whatever definition of memory you want to have, and be able to reason on the information of this memory. And if if the task is complicated, like the memory will have to include a lot of information, and the agent should be able to access this information and to figure out which pieces of information are relevant in order to proceed on to the next step. And then the last part, I would say, is what is usually called human in the loop. There is the need for the agent to interact properly and effectively with a human. And this is because of, I would say, I can think about at least two reasons why. First, depending on the task, you as a human, you want to have some control on what the agent is doing. If you want the agent to send an email for you, before clicking send, you want to check that is everything okay, that there is no hallucination, there is nothing wrong going there. So first is a matter of like having the control and not letting the agent go wild. And the other thing is that something that I'm truly interested in too, and that probably is the thing that I'm mostly interested in too, is that as the two of us like start doing a task together, right? And you ask me to do something, and it's the first time I do it, let's say. You would not expect that you give me the task, maybe a complex one, and I go through it alone. Most likely, I would come to you and tell you, hey, Chris, this is not clear. how should I do that? Or can you give me like a bit more information on that part? This is new. This is normal. You would expect it from me. So why shouldn't we expect this from an agent? I mean, an agent might not have all the relevant information that is needed in order to perform the task, or might need some clarification, or might get into some local minimum in which it doesn't know where to come out from. So I guess like human in the loop is, I would extend this concept to like allowing and actually encouraging the interaction between the human and the agent in order to jointly perform the task. So for me, these are probably the four main aspects when we talk about agents. Then for for autonomous agents that are those that I'm currently working on, there is an additional part which makes it even more interesting, is that it's not only a matter of reasoning and producing an answer, it's a matter of interacting with the environment. So the difference between an agent and an autonomous agent is that the agent is only getting from you the textual input, using the tools through the API and providing an answer. While autonomous agents, you give them the task and then they take, like they open the browser, they click something, they have to perform a lot of things, and they need to have a lot of interactions with the environment that of course increase the difficulty of the task, because there are a lot of things that we as humans do without even thinking about that. Closing pop-ups, accepting cookies or refusing cookies, or scrolling here, scrolling there, going up, going down, jumping from a page to the other, and so on. That machine, like LLMs, are not used to that. So how do we make them to perform? It's fun.
Yeah, a lot of, even as an amateur and I would say an AI enthusiast, is it baffles my brain in terms of how it's trained and managed. But in terms of the research that's being completed to kind of drive this technology forward and some of the key challenges that you're seeing to advance the field, you kind of touched on some of them there already, but what research are you currently working on, or the field in general working on to kind of move agents forward?
So I would say I'm looking at my note. Uh, so I would say there are a few things. First of all, currently, especially for autonomous agents, there is no much data, or probably no data at all, about what you can call trajectories. So as you are given a task that implies you to, for example, go to booking.com, select the date, and so on and so forth, and you have a set of steps. Like this set of steps, you can call it a trajectory. Like we can call it a trajectory. Okay, so in the training data of current LLMs, there is probably not almost nothing about this. Therefore, this information is not present in the pre-training, and therefore is not present in the foundational models. And this, of course, is a big limitation for models to perform well on this, because of course you can do some post-training, but without having think about coding, right? At the beginning, code was not included in the pre-training data of large language models, and models were not very good at coding. Then they started to include it more and more data. So the basic knowledge about coding was already there when the foundational model was created. So we are in a similar situation now with this, like trajectories are not there in the foundation models. Therefore, they really have no clue about what's going on. And so I believe that one direction will be, I don't know what they're doing in like the big labs of the big players, But I believe that like having this information in the pre-training is definitely something that is needed in order to make the model able to become better at this. And then like one other thing that I believe is it will be interesting, at least from my point of view, is, well, a couple of things I mentioned them already. Let's say that as you go through steps and you explore some website, and then you realize that you're not getting closer to the task that you want to have, and you actually went down the wrong path, which is super normal. I mean, when you search for information on the internet, you might take several steps in the wrong direction. And then at some point you say, no, this is wrong. I should go back. So how much do you have to go back? Till which point do you go back? And I mean, know that sometimes it's even hard for us. I mean, I myself find myself a bit lost when I have to look for stuff, and then maybe sometimes I even give up and say, okay, I didn't find it. I don't know if it's not there or whatever. So this is this requires a sort of reasoning capabilities that are definitely related to the general reasoning capabilities of the models, on which there is a lot of work going on. But it's slightly different. I mean, the reasoning capabilities that allow AlphaGeo to win or to get the silver medal at the math Olympiads are different from this kind of reasoning. Of course, probably there is a relation between the two. So this is definitely a direction of the research that I would find very interesting. And then like another direction that I find extremely interesting is that, of course, there is, as we know, like pre-training and post-training and whatever. But so as you explore the world, as you explore the world, you accumulate information about about your experiences, and then you reuse this information at a later point in time. So just to be more concrete, like when you first saw the accept cookies thing, maybe you didn't know what it was and you had to find it out. And then you started to see that it was almost everywhere. And then you say, okay, you create this mental schema in your mind whereby you say, okay, I can accept them most of the time. So basically this happens because there is like an event memory in which you store, that is usually limited and it's pretty short, where you store information about specific events. But then there is like you can call it sort of parallel semantic memory, where you abstract from the information that you have from the specific event and create a more longer term piece of information that you will access to and you will remember. So I believe a very interesting research direction is how, as the agent explores the world, as the agent interacts with the environment, how can we make it like store single events and abstract over the single events in order to create like more long-term memories and pieces of information that it can reuse in future interactions. So I know this might sound maybe a bit abstract. I hope it was clear.
Yeah, no, really clear. I think something I find fascinating is kind of the inspiration from maybe how we as humans reason and using that in the system. And it'll be interesting to see how that plays out as well. I think if we end up going down that route or something completely different. So yeah, it just makes sense. Thanks for sharing. In terms,
The human. Sorry to
no,
add
please.
something on this. The inspiration from human is not is not necessarily because I think or I believe that machines should replicate human behavior. Sometimes they do not. And for example, I remember that when there was this, I don't remember precisely the details, but when AlphaGo like became like managed to beat the world champion and so on. I remember I read somewhere that the the best human players in the world would say like that AlphaGo was adopting strategies that at the beginning seemed to them completely nonsense, but then after many steps they turn out to be like brilliant. So, and I'm not an expert of Go, I'm not an expert on AlphaGo, but what I found interesting back then, it was this, no, the idea of saying, okay, I mean, the model came up with a strategy which is completely different from mine, which I'm the best or almost the best in the world at doing this game, at playing this game, and it makes sense. So what I'm saying is that models should not necessarily replicate human behavior, but on the other end, like taking inspiration about what we do, about like the general approach whereby we explore the world, make a lot of mistakes, and learn from that mistakes is probably a good way to go, rather than expecting from a model to like perform a task, maybe even for the first time, and be straight to the point. This seems a bit unrealistic to me. I mean, it doesn't look possible, to be honest, or at least it doesn't look scalable. So it's just this general intuition, I would say.
Yeah, it's super interesting. I'm very excited to see how this all plays out over the next couple of years. You kind of touched on some use cases there in terms of booking or other areas. What areas do you see agents having the most impact in the real world, I guess?
Well, I believe the answer here is pretty straightforward. The idea, from my point of view, is to let the agents do a lot of those boring or not boring, but a lot of these tasks which require some intelligence, and but they are not particularly stimulating, or they are very repetitive, and they are and they are always the same. The example that I was giving earlier, let's say, is pretty yeah, it's a good one. The one of booking a flight. No, for example, I often travel for work, and every time I do that, I mean, I know, for example, that my company gives me a budget for traveling, and every time I do that, I have to say, okay, I need to stay 5 days in London, and I have this budget, and I need to find, and I want to go on those dates, but I know I have some flexibility. For example, I can fly either on Saturday or Sunday, let's say, and I would like to stay in this area around the office. So it usually takes me some time to plan my trip, because I have to go see the flights and then say, okay, I have this, and then check the hotel and say, but there's no availability, so I should fly the day after. But the day after is Christmas, and so the prices are 3 times what they were the day before. So it's not something particularly complicated. It's not rocket science, as they say, but it's not even that straightforward. So I see like there are plenty of, this is a specific use case, but there are plenty of cases in which we perform tasks which require time, require some thinking, and the thing is they are very repetitive, and they have to be done over and over and over and over again. So I believe where the agents come in is, especially autonomous agents, is this part. So be able to make automatic some not that straightforward tasks. So as I was saying, tasks that require some intelligence, but that like having systems that do them in an automatic and reliable way would really benefit a lot of people and a lot of business.
Yeah, and do you think we'll have maybe lots of little different agents or applications to do different things, like a booking agent, and then I don't know, like a software agent,
Of
or
course.
we'll end up and then do you think at some point we'll have maybe like one AI assistant that will do everything?
That's a good question. For example, like there is OpenDevin, which is, well, now it's called OpenAnds, which is like this super good agent for coding, let's say, no? Probably if you ask the same agent to book a flight, it's not that.
Yeah,
And so the main approach going on nowadays, at least the one that I wouldn't be able to say if it's the main, but a general approach is to have a multi-agents setup. So basically, you have a master, which is the agent that receives the task, and then you have a lot of different agents that the task can be handed over to, right? So this makes sense. The problem here then becomes like, what is the what do you include in the cohort of agents that you have, and how? I mean, in some cases, like coding and booking a flight, the difference between the two is pretty straightforward. But there are probably cases in which it's less clear which agent should do what. So multi-agent approach is I believe the way to go. And sorry, at present, probably the most likely and the most reasonable approach. What you're saying about having a single agent is, of course, the dream. Mostly from a research point of view, like saying, okay, how do you make an agent that is as good as this at everything? Honestly, I don't see it in the very near future, because it's hard. I mean, people now we're talking about coding. People at OpenAnds are like surely working a lot on this very specific thing, like how to generalize and how to make it as good as this to and potentially any domain is hard task. It's super interesting one, but I probably not see it something that will happen in the very, very near future.
Fair enough. We can dream, can't we? But let's see. For the final question, I've wrote down predictions for research over the next 3 to 5 years, but I think that might be impossible. I think that's.
I was like, it was when I'm looking at my notes, and I have a couple of bullet points, but then I thought, okay, this is hard.
It's above the hardest question.
No, okay. I probably, I mean, I was hoping to come up with something smart to say, but I believe I don't have that much, because what I think is that many of the things that I put here in my notes are something that, in a way or another, I have already touched upon in the previous parts of this conversation. So I believe, something that I think it's probably going to happen, and it's pretty realistic to expect, is that models and agents will become more and more parts of our daily life. We'll find a way to have agents which are, and I'm pretty sure about this, we'll find a way to find more agents which are more reliable, which are good at performing tasks, which are able to store information and to reuse it. And I tend to believe that they will become a tool that is widely used, and it's widely present in our lives. So this is something that I'm pretty convinced about. And from my point of view, given also my humanistic background and so, what I find really interesting is how, something that I was mentioning earlier, like how will we improve the ability of the model to jointly perform tasks with humans. So I believe that the current state of today, I'm now repeating something that I've said in a different form, but the current state of the things today is, I am a human, I give you a task, go ahead, do it, come back to me when you're done. And I believe this paradigm will shift, at least in part, and it will go more, I'm a human, you're a machine, I'm leading, but let's work on this together.
Yeah.
So this is the direction that I'm more interested in too, and that I believe like it might open the way to a even broader adoption and spread of LLMs or agents in general.
Yeah, I think that's a really nice way to put it and to close on. So yeah, thank you. I'd like to thank you, Marco, for coming on. Really appreciate you and your time and sharing your knowledge with everyone. So yeah, thanks a
Okay.
lot.
Thanks a lot, Chris. It was nice.
Thank you. That's it. We're done.